Hello, everyone. Welcome. Thanks for joining us for this first talk in the Algorithmic Pattern series. I'm very excited to be introducing Laura Devendorf to talk about weaving and her approach to it via her AdaCAD software. Thank you very much also for Claire Hill for providing the live captions for this talk. Before I introduce Laura, while we're warming up the stream, I just thought I'd read a little paragraph from a paper called Digital Craftsmanship, Creative Collaborations with Machines, which was written by Christina Anderson with Ron Wackery, also with Laura and myself as co-authors. I thought that would be a nice way of setting the scene also while people are joining. So this is about looms and weaving in particular, and craft in general. And so it starts this little excerpt. For now, let us consider machine as a name for any human construction, from the physical to the immaterial. The machine is a contraption. It entangles and incorporates us. As a contraption that we can become a part of, it invites us to express ourselves in different ways. It allows for emergence and making of new things. The machine is a construction that holds the mechanics to effect change. Something is added, something is removed. Wheels whir and squeak. Weavers whisper the number of repetitions: 1, 3, 2, 4. I just thought it was a nice thing to start with because it sort of sets the scene in thinking of a loom as a machine, as a technology, as mathematical, but also as something which is part of us and we're part of. So too often I think technology is presented as something that happens to us. It's nice to think of something which is developed over thousands of years, as looms have been and are sort of culturally situated, but very much very complex technologies. If not the loom, then definitely the weaving which is done on it is of amazing complexity, as we'll see. So yes, this is the first talk of the Algorithmic Pattern series. I think it's interesting to put these two words together, algorithm and pattern. We often think of an algorithm as something kind of cold or something which controls us on social media or this sort of thing. And on the other hand, we think of patterns sometimes as being based on repetition and sometimes, especially in music, is even a pejorative term, like a pattern is something which, if you accused a composer, at least one in the European tradition, of just making patterns, they might be quite offended by that. So by putting algorithm and pattern together, it kind of points towards a different meaning, I think, of something which is about our senses, about our perception through pattern, but also about systems and rules and the exploration of a world of language through algorithms. So I hope the 6 people who will talk during this series will give very different, interesting perspectives on algorithmic patterns, either fleshing out what it might mean or challenging it. We'll see what happens. I hope you're able to join either the talks live or the archives after the event. Anyway, I think the stream is nicely warm now, so I'd now like to invite Laura to join us to introduce herself.
Hello.
I'll leave you to it, Laura.
Thank you so much. That was a really lovely introduction and some nice reflections. And it's been really heartwarming to actually see the comments coming in from folks, and some familiar names, people I know, and some people who I've been maybe low-key web stalking. And so I'm glad to have you all here. And again, just thank you so much for including me as part of this really amazing series. And yeah, I'm completely honored and a little bit nervous. So let's see. I think, Alex, you might have to add the slides. Thank you. Perfect. Okay, so today I'm going to talk about the algorithms of weaving, or just the way that I've been thinking about doing my weaving encodings by building software. So I built a software tool called AdaCAD, which I've been working on in collaboration with students and weavers and non-weavers who maybe are interested in soft and flexible electronics, and trying to figure out, I don't know, different ways we can think about weaves and different ways that weaves have been thought about and the way that they've sort of always been algorithmic, and how a software tool can play into those histories and not necessarily replace them. So the first thing I want to say is that I feel like I'm just part of a long-standing community of people who have always seemed to existed through recorded history and maybe unrecorded history, who've become completely enamored with this kind of digital material calculus that is weaving. And I like to say this because, maybe similar to what Alex was saying, it's not like this technology is imposed on us. Weaving is so interesting because it's a structure of encoding so many different things. It's mathematical, it's visual, it's aesthetic, it's cultural, it's meditative. It's porous, so it soaks in smells. It gets tangled as you wear it. And so it becomes this really lively material, and lively kind of, if you think about it, like a numeric system for calculation. And it opens up these ideas of calculating and mathematics to all different kinds of material expressions. And I'm saying it this way about mathematics and expression just because that's something I've always been drawn to. So puzzles and patterns and organizing and things like that. And I imagine maybe most of the people here too have the same kind of fascination. So to give you a little sense of who I am an assistant professor at the University of Colorado Boulder. I'm in my office now. Ta-da. And I'm part of the Atlas Institute and Department of Information Science. I also hold joint appointments in computer science and intermedia art writing and performance. So across all different programs, very interdisciplinary. My background was actually, I did a BA in studio art and then a BS several years later in computer science from UC Santa Barbara. And after that, I did a PhD at the UC Berkeley School of Information. So I've always liked to operate in these spaces that are technological, but perhaps not situated in CS, but in this periphery of other sociocultural concerns. I work as part of the Unstable Design Lab. And so a lot of the work I'm presenting today, I can't take full credit for. These have always evolved in conversation with the people and students that come in and out of the lab. And I've been really lucky to work with an amazing group of people in this picture from the before times. So I think we did an updated picture, but this is maybe just a sense of the lab and the kind of people we put together, and a few links for things like GitHub and Instagram, and our lab webpage is where we catalog a lot of projects. We host an annual experimental weaving residency, and so we'll be hosting this again, another open call this year. Our experimental weaver in residence this year is Etta Sandry, and so that picture at the bottom was her giving a presentation about her work, because she too has this amazing method of understanding and encoding her weave structures, which you can kind of see in these sketches that she's made. So maybe there's a whole different talk series on weavers just sharing their sketchbooks, because they're always just really fascinating. Okay, so keep an eye out if you're interested. If you're a weaver or an algorithmic person who's interested in weaving, let me know, and we'll do that call again in the fall. Okay, so to say more about digital material calculus. This has been a long-standing concern, and so basically I dropped out of engineering to pursue art because I was tired of things being so rigid and clear, and I had a bit of a crisis and really loved art. But then I discovered how much I loved programming and algorithms, and perhaps realized that I naively left engineering because it was a kind of craft and art form in itself. So I went back to school for computer science and studied a lot of things like cryptography and programming languages, and just loved almost the certainty and comfort that comes from pattern and order. So when I went to my PhD, people were really interested in 3D printing. And the thing I loved about 3D printing was being able to sculpt with algorithms, right? You could write geometry algorithms and meshing algorithms and make new kinds of shapes. But I hated this idea that you had to give them to a machine to make them. So my thesis research ended up becoming a 3D printer that you were in control of. So it's essentially a laser pointer that draws the 3D printing paths that you follow by hand. So the idea was it could give the materials more say in the objects that were created. And it shifts the activity from delegating it to a machine to being both involved in the design of it and the making of it. So really not doing this like plan and make, but seeing the digital as a material and then the physical as a material, and kind of noticing those frictions or the resonances they form with each other. After that, I was fortunate enough to get involved in a collaboration with Google, and they were interested in embedding electronics and fabrics. And I didn't know anything. I knew what a woven fabric was because I had worked at a clothing company for a number of years, but I didn't know anything about weaving at the time. And so this involved collaborating with a weaver to understand how we could embed different conductive yarns into woven structures to achieve different kinds of display elements. And in doing this, I just realized there was almost no discussion of weaving or textile making at the time as part of this digital fabrication landscape. And it felt like a really huge oversight, and I couldn't help but feel like it was quite gendered, that we were just looking at these big traditional machine shop machines that were going to give us all this precision and control, when really there was a history of people who were already makers, making amazing things by hand, or even with machines. And so it just became a space that I wanted to play in more. And I think I ended up sort of seeing the loom as my ideal 3D printer. I can design a pattern, but then I have to negotiate with the materials to get it. So as I started at CU Boulder, I really wanted to understand, one, how we could preserve the role of craftspeople in these smart textile futures, because I was a little afraid of the future where engineers invented textiles. And engineers are craftspeople in their own way, but I felt like there's a history of skill that's often unrecognized as technical. And I wanted to maybe create a platform where that technical knowledge could be held in esteem, right? So I wanted to create a new tool for making these advanced fabric structures, but do it within the vernacular of weaving instead of the vernacular of some other discipline. Okay, so this is going to be a quick segue into the many encodings and alchemy of weaving. And so this digital material calculus often involves encoding. So when you're weaving, you have different representations for the same thing, different abstractions, different, I don't know, if you're into Latour, you could quote some Latour here and say different immutable mobiles or boundary objects or things that allow you to kind of highlight different qualities of the same object. And so this on the right is a swatch, a woven swatch that's actually a press button. And so this is like an interactive cloth prototype. It'd be interactive even if there wasn't a press button in it, but for the sake of showing technology, we made it into a little press button. What's happening with the materials here is that it's a double layer weave structure. And so the way that you align the different instructions of the weaves can give you more than one layer. And so that's also just kind of magical that all these things are encoding the same thing. So on the left, we have the draft, which is the traditional encoding of a woven structure. And none of these things really look like each other, but they're all sort of speaking to the same thing, and they're all bringing out different qualities of the same thing. And so the encoding of the draft has been the way that's very common for like trading and sharing weave patterns across different people. But historically, people were weaving on warp-weighted looms. So even in this Homeric myths of the Odyssey and the Iliad, there's a lot of references to weaving. And I did some research yesterday to try to find an exact quote. But what weavers were doing is they were walking back and forth across these looms that were oriented vertically, and they were singing as they do so. And I'd like to believe that they weren't just singing idly, they were singing the pattern, right? So if you have 1,000 yarns, it becomes really tedious to count every one. But if you have a rhythmic encoding, like a song or a pattern that can help you figure out where to pick, that's a way you can actually encode your pattern in song. It also has another history of, what is it? Philomena and, oh gosh, the nightingale myth. Anyway, her tongue was cut out, and so she only spoke through her weavings. And that was kind of a poetic way of saying that these structures in cloth can hold stories. And if you look at practices of like steganography, they're very literal practice of encoding literal messages and stitches. So just a lot of interesting histories. Somebody else that I've really admired is Ada Dietz, who was encoding her color patterns as binomial equations and trinomial equations. So she used all these different equations to kind of create different color mappings and groups and came up with her own encoding for all this. And this is still happening today. And I use this slide to also just highlight to people who might not already be familiar that weaves are not just flat. They're three-dimensional mechanical chemical structures. We don't always see them this way because we're interacting with them often on the periphery. But if we really come to look at them and design them as little structural bodies in themselves, we can get all these different mechanical qualities out of them. So at the top, that might be a whole woven garment that kind of comes into a different shape. Or Philippa Brock's work, who's making really amazing dimensional and these are kind of like waffle structures. Or Victoria Mangianello, who's weaving with surgical tubing, which I thought was so clever, and then running fluids of different colors through the tubing so it actually animates in these different ways. So that's the other great thing about weaving, is that you don't always have to use yarn. You can throw almost anything you want in these structures and play around. There's a lot of open space. So here's another example of a contemporary weaver, Catherine Walters, who's somebody I've been collaborating with. And I like this example because she's been laboring over how to make a box that you can weave flat that will fold into a box. But what's most interesting to me is the calculus that she does to try to get this to work. So her patterns, and she's come up with a collaborator with a whole system of notation for organizing what's happening at every different part of this structure so she can get it to behave in the way she envisions. So those are some encodings. I have my own encodings that I like to play with, often that deal with sensors. And so this is a fabric that has 6 different force sensors embedded in it, and it's recording the way people touch it over time. So I liked this as an example of the friction between digital memory and the physical memory of the yarns. So this is encoding touch. To do that, you have to create these structures that are multi-layered. And so this is encoding the knowledge of how to make a woven force sensor. This is another project, which is a very similar concept, but body worn. So this has 22 force sensors that I wore across my body for a day to kind of understand how I interacted with other objects, whether they be my children or a couch. But if you could just sort of take my body's memory of where it's pressed and pushed, what different kinds of things become available. So in here, it was just encoding this feeling that I have these fleeting experiences with small children that I'd like to remember somehow. So how can my clothes become dirty with those memories? But it was also a coping mechanism. It was an encoding of how to survive in a pandemic when I can't really leave my house. I'm a full-time caregiver, I'm teaching school, and really transforming every aspect of your scientific practice into your home was an interesting kind of thought experiment. So AdaCAD became the way that I think about weave structure. I'll go back to that actually, because it has really come from a ton of conversations with weavers and technologists and people who are incredibly inspirational and supportive, and that I can't sort of give credit to enough in helping develop these things. And AdaCAD started like this. It started thinking about the draft as a canvas that you would draw into. And we kept it like this for about 2 years, because this is sort of what weaving software looked like. But in engaging with more weavers and the local hand weavers guilds, I realized that this kind of already exists. This format is already done really well, and it's already been developed primarily by the weaving community itself. So they have tools that can do these kind of weaving patterns and this style of drafting already really well. And I didn't want to be in the position to tell someone to use a new tool. So I decided that I wanted to like lean it in more heavily to the weird and wacky way that I was starting to think about weave structure. Sorry, that was a second picture of that last slide. And that was much more in this language of like a flow diagram. So if we think about every weave structure or stitch as a kind of function, how can we stitch these functions together to create new kinds of structures, or to just create a kind of design system that's a little more flexible to changes? And so when you have this canvas model, the only insight you get into how it was made was like an undo feature or saving your files over time. And I wanted a way to actually encode the process and the methods of thinking. Like, how did I get to that particular structure? And what are the relationships between structures that allow things to happen? Okay, so this is where the talk is going to get a little more interactive, and I hope that will be a welcome thing to do after so much blabbing. So I actually want to introduce everyone to AdaCAD, show a little bit of about weaving, let you play with it a little bit, and then really just start opening up to questions so we can have a little bit more of a conversation. And so for those of you who may not be weavers, it's helpful just to understand some key terminology. So this is a very basic diagram of a weave. And so these black up and down yarns are called the warp. And so when you're weaving, and you might have done this in school with paper weaving, you create a parallel system and you put it under tension. So usually there's beams on either side that are holding those parallel warp yarns taut. And then you take another yarn, which is either in your hand or on a spool, and you weave it in and out of the taut yarns. And so when you're doing this by hand, you're usually manually going under a warp, over a warp, under a warp, over a warp. When you're doing it by a machine, the machine is lifting certain warps and you're just throwing your materials in the middle. And that lifting is called a shed. We're not going to need to really know that term too much. But that's just the context. It's good to remember a warp and a weft, and that the two variables, the most primitive units of this calculus, are the relationship of the warp to weft at every place they cross. So in a draft, a black cell is a place where the weft goes under the warp, and a white cell is a place where the weft goes, over the warp. Every time I have to stop and rethink it. So let's go. If you're able just to type this into your browser, we can follow together. I see it was dropped in the chat. I'm just going to take a second to switch my screen. If the organizers have any feedback or any questions coming up, just feel free to let me know. So let me go ahead and just share my screen again. Okay. I'm also happy to do a show and tell. I have lots of prototypes behind me. And a bike helmet. I didn't make the bike helmet. I just used the bike helmet. So if somebody wouldn't mind sharing my screen again or putting it back up in the main view. Perfect. Thank you. Okay, maybe send like a thumbs up if you were able to get this loaded. And send a very sad face if you weren't able to get it loaded, and tell me what browser you're using so I can debug it. All right, so we're all cool? All right, I'm going to assume we all got it loaded. Again, the URL is in the chat. It's adacad.org. If you weren't able to get it from that URL, you can also come up here and open a new workspace, browse examples, and it's this lesson 1 here. So you can get to it directly from the software. And then when we're done, you can also look through some of the other examples that we've already put in the software. So, oh, great. I just canceled it. Let me go back. So this is a weave draft, like we've been talking about. I'll move it around. Hello, I'm a weave draft. If you want to look at it more closely, we have this little expansion icon. This expansion icon just lets you see every individual grid cell. If you don't like seeing things tiny, you can go ahead and, oh, it's funny. I'm actually looking at the screen share and not at my actual screen. So you can expand it bigger if you'd like. So this is our draft, and you can see each one of these grid cells has a different value in it. So like I just said, a black cell means this heddle is up and the warp goes over the weft, and a white cell means the heddle is down and the weft goes over the warp. I added a third cell because when you're doing like inlay weaving or shape weaving, you actually need a third value to tell the software that there's no weft at this location. So this would say we're not actually pulling it all the way across the thread. We're just pulling it part of the way. So this is what I call the null set. When you're designing drafts, there's kind of 2 components to keep in mind when you're thinking about weave structure. And those are called floats and interlacements. And so an interlacement is any place where the yarn switches from the front to the back. And an interlacement basically takes 2 yarns and interlaces them. And they don't just interlace flat like this, they sort of push and pull against each other. So these are places where the cloth will be more tightly structured or tangled. And they create air in your structure, and they create kind of rigidity. The next kind is called a float. And a float basically means that your yarn's staying on the same side of the cloth as it's been on. And you can float in the weft direction, so from left to right, or the warp direction. And the color of the float tells you which side of the cloth you're going to be floating to. So this also speaks to the idea that you're not weaving something that's flat. You're weaving something that has this, if you're a geometry nerd, it's going to have an arc that's normal to the surface at the cloth at that section. And what's interesting is you can actually, I've done quite a bit of tests with these arches. So by float length, there's sort of the sweet spot. So you can get this perfect float size so that it arches, and every time you press it, it'll bounce back up. Too long, it kind of collapses. Too short, it doesn't rise up enough. So floats can be really fun just as a starting point to play with structure. Okay, so if you want to think about cloth, people usually start with this most primitive kind. Shouldn't say primitive. But one of the most standard forms of weave, which is called plain weave or tabby. And this structure has the maximum number of interlacements because at every edge, there's a black cell on one side and a white cell on the other. So tabby stitch is going to be your most spaced out, airy, thin structure. Structure with more floats is going to be more densely packed because every time you push down a new row, it has more room to stack against the previous layers. And so then when you get into these structures, you can start playing with color because if there's more wefts on the surface, your cloth is going to look the color of the weft. And if there's more warps, your cloth is going to look the color of the warp. So what AdaCAD starts to do is it starts to play with these families of structures. And so different structures come in different kind of familiar groups. And different, there's kind of three that people cite as the primary structures. One is tabby. So that's what we've just looked at. And within these groups, there's different derivatives that are still a form of tabby, but they've been modified in some way. So I call these things in AdaCAD operations. Whee! And if you want to, you can go ahead and just play with changing the variables in these operations. And so this is just creating tabbies of different sizes. So this is a really huge tabby, but you know, maybe that's what you need. Maybe you want to take 27 tiny little yarns and bundle them together, because that's the effect this will have. The next family is called twill. And so with twills, you're basically offsetting the rows by one at every pick or every row. And so you define the over-under pattern of the first row, and then it shifts it to the left or right. So here we can add more unders. Maybe we can add more overs. And you can go ahead and slide that little toggle to move it from the left or right. You can also just swap the number. So again, this would be weft facing. This would be the color of your weft. If you want it to be warp facing, you just go ahead and switch those colors. Fun fact, this is always going to be what it looks like on the back side of your cloth. And this is going to be what it looks like on the front side of your cloth. Satin is another structure, and it's a little more interesting because it has to do, I don't know, I think you can get into some deep math with the satin structure in terms of different like modular math. So with a satin, you set the size of the structure you want. So how big do you want your satin to be? And then you define how many moves you want between each interlacement. And the goal of a satin is to put as much space between the interlacements as possible. And so what you'll see is not all numbers create a well-formed satin, but the certain magic numbers, like here, let's see, 6, 6, 7, 5. No, that doesn't really work because those warps are too close. Anyway, as just a nerdy thing, I kind of like to come in here too. And there's just a fun way you can experience the math by watching it. Like that's 1 shift, 2 shift, 3, 4, 5, 6. And then if I just hold this down, it creates this nice circular animation, which I find fun. And again, you can sort of just use this toggle to say, I want it weft facing or warp facing. Okay, we have lots of other structures you can play with. I store all these operations in this icon here. This is the operations tab. And there's different groupings. So structure is all these different groups of structures like we've been looking at. And then we'll get into some of these other ones that get a little weird and wild and wacky. So yeah, while you're here, you're welcome to just, if you change something on your local browser, it's not going to change for everyone, so don't worry. And you're welcome to play. So here I can just write in a list of numbers, and it'll create me a twill with that pattern. Let's go back so it's not in the way. So one of the things that becomes fun too is you don't have to stay with traditional like weaving constraints. You can start writing in different functions. And so here I wrote this function that's just called random, and it uses a random number generator to assign the values to each cell. And then you can just give it a percentage. Like if I wanted 10% of my picks to be warps, I change that to 10, so I get a weft facing structure. If I change it to 90, I get a warp facing structure. If I change it to 50, I get something weird that's technically well balanced. So I've been enjoying that as well. So then what you can do is you can start adding these structures together to create new structures. So if we want a zigzag, we can use something like join left. And to use this, we take these two functions and we stitch them together. So we take the outlet from one, and we drop it into the inlet of the other. And then we can do the same thing, and it'll just join those side by side. And if I keep adding them, I can keep joining them. And then what's nice here is if I actually change these values, I can change the whole kind of subsequent pipeline of the structures. And what it's doing here in the join left is it's actually calculating the size the structure needs to be to evenly repeat as you tile it along your cloth. So it does some of the little math I was doing by hand just in the machine. Another one that I like is this make symmetric. So you can just pick a corner and it'll rotate it around that corner. Or you can interlace two structures together. So that creates a kind of structure called an overshot. So you take a tabby, you interlace it with a basket, and you basically take one row of each structure and alternate them to get the resulting structure. So each one of these will have really unique effects in the cloth. And so it probably feels like a lot if you're not a frequent weaver, but you can also approach it just as like fun math with bits. And to sort of emphasize that, I also created these just binary bitmap functions. So if you take two structures and you do an XOR, it comes out something like this. You can do an atop, which just basically puts one structure on top of another. You can mask it. So you do an and between two structures or an or between two structures, and you get slightly different things in each case. So at some point, you're probably going to want to weave something, and we actually allow you to do that. I'm going to skip transformations, but you'll know they're there. You can also play with those, just shifting different things or flipping them. I did this little demo just to show what it might look like if you're actually making a weave. So if I take a twill, I make it symmetric, and I fill a rectangle with it, I get this kind of really floaty draft. And what's interesting is that depending on the way that I use different colors of thread, that fabric is going to look totally different. So structurally, it'll be the same, but visually, it'll be really different. And so here, I'm just using orange warp, blue weft, and you get something that looks like the draft. But if I start putting stripes in the warp and weft, I get something that's a little wilder. And here are just kind of different stripe combinations. So this becomes kind of fun just to play around. And if you do want to make like a color palette to add, I just create a little blank draft. I open it up. Let's see, I'll select some different colors here. Let's see what happens if I do that. And then I'll get rid of that. I'll put in this. Ooh, that one's kind of cool. I'd want a t-shirt in that. So then if you actually want to weave it, you can actually follow different kinds of instructions. So one is you could just follow the draft manually, just going each row by row and calculating the over-unders. If you're a frame loom weaver, it'll actually compile your threading, tie-up, and treadling. And if you're a jacquard weaver, you can just create a rectangle that's the width of your loom. Ooh, I don't know how exhausted it is, but yeah, let's talk. And then I have a few other helper functions, like a selvage function, so you can add in a selvage to either side. So from there, I can get really, I can go deep on some of these things, and I don't want to bore everyone. So I think it would be kind of amazing to turn it over to questions, to maybe speak to this first question, which is how exhaustive is the set of operations? Oh my gosh. That is like, I feel like that's almost like an impossible question, because there's definitely different tapestry techniques that people use that I wouldn't know how to encode in AdaCAD. Because they do things like, oh, I'm going to loop the yarn and then I'm going to pass it back through this other one. So I'd say maybe more intricate handwork you wouldn't be able to do, but this would be more situated for machines. But if you want to look, there is an example. Browse examples. There's one called Operations Playground. And every time I add a new operation, I add it here. And I'm also okay with like operations for hire. So if there's an operation you want that's not in there, I like to make these things. So yeah, here you can just see every operation that we've made so far. This one's kind of fun. You can upload an image and then assign different structures into it. So let's see if I get rid of this. Let's see it a little bit better. Uh-oh. Probably crashed my software. Whoa. Get in there. Oh. Whoa. That's trippy. It turns out that I might be, apparently there's a certain class of weaver that likes drafting more than weaving, and I'm worried I'm bordering in that category. Yeah, and there's also some kind of fun, we did some machine learning on different like weave draft sets. It does nothing interesting, but now we can say we used machine learning, so maybe people will think we're actual engineers at some point. Yeah, so let's turn it over.
Obligatory machine learning. Yeah. Thank you so much, Laura. It's really amazing introduction to weaving. But yeah, really broad and also really deep at the end, and lots more to play with AdaCAD in our own time. Yeah, I'm not. I think there's something about maybe from the perspective of someone who's not familiar with weaving. There was one name you mentioned at the end, Jacquard, which I find when I talk to people about computers and weaving, it's the first name that comes up as the idea that this is sort of the starting point of the connection between computing and weaving with Ada Lovelace and Babbage and so on. And it's like this kind of really nice, neat origin story, which is really suspicious because it's just a bit too neat. And actually, until that point, you mentioned all these mathematics, this very incredible way in which these different patterns can interfere with each other, how they create these three-dimensional structures. And this is all really ancient knowledge, I suppose, which would have been around long before Jacquard. So yeah, I'm just wondering if you could kind of put Jacquard in a historical perspective in terms of where computing and weaving interact with each other.
Yeah, I mean, I think the best version of the story that I've heard is there's a design podcast called 99% Invisible. And they had a small sub-series called Articles of Interest, was like the history of different garments or the history of pockets or the history. They did one that was the history of denim. And as part of that, they really went into more detail about that link between the Jacquard loom and the computer, which I thought was interesting. And so apparently, according to them, IBM became a business in the early 1900s because they needed a way to count the census, and they needed a fast way to count the census. And so basically the punch cards from the looms became the inspiration for like, oh, this is a way we could actually start doing calculations and totals on really big sets of data. So it was sort of like the original Scantron. And then from there, IBM started developing that out into different computers. But that binary logic, I think, was kind of always there. Like, I don't even want to say that it was the Jacquard loom that did it. There's part of me that wants to say that it was already kind of implicit or known thousands of years earlier, right? And it became maybe there was new machinery around to make it tangible or to automate it in a certain way. But I guess my desire is to see that history as like, I think we already kind of knew it.
Yeah, I think this is super interesting. Yeah, I've talked to another weaver, Ellen Halisius-Gluck, about this, who's published on this historical aspect of weaving as computing. And it's interesting how Jacquard is really at the point where, as you say, weaving becomes automated. and somehow his name gets attached to weaving in general, which seems a bit unfair. And it's almost like it's the end. It's like the end of the human relationship between weaving and computing when you automate it, because before that, all these mathematics and so on was a very embodied practice. So I think it's interesting how things like denim and twill and all these color and weave effects and all these different computational things don't really have a name attached. They have names, but they don't have a person who kind of claims ownership of it. I'm wondering if that's part
Jean-Luc
of
Twill.
Yeah. Oh, was it? I don't know.
No.
I'm wondering if that's somehow why we don't see it in the same light. Is we don't have this kind of hero figure to associate with it. We just have this ancient practice, mainly practiced by women, sort of exploring all these computational structures. And also, sorry I keep talking, but I really liked how you talked about coping with your introduction of your artistic work, and how I was just thinking how weaving is really a technology for coping. Thinking of Ursula Franklin, who talks about, on one hand, holistic technologies which are for coping, and on the other hand, technologies which are for growth and overgrowth, and how there's this whole feminist perspective on technology, which is somehow hidden from the history of science and technology, and yet is, I mean, with all the problems we have in the world, we really need technology for coping.
Right, or technology. I think for me, I actually don't know the theorist you're speaking of, so I want to look it up, and I'll follow up with you on that later. I think the way I started to see it, and the way all the 3D printing stuff happened too, was I had a baby, and I was doing research on 3D printing while being pregnant. And there was a bit of a like, why aren't I a 3D printer? Like, look what I'm doing. I'm not even trying. I didn't even have to like, all I have to do is eat a ton of weird things. But it felt to me like it was more about a relationship to control than it was about a machine versus not a machine. Because we can approach machines without wanting that certainty. So yeah, David Pye is a theorist who talks about like the workmanship of certainty and the workmanship of risk. And so craft being more oriented towards risk. But I get really into this, and then it does make me start thinking like maybe the key is that we just need more technologies for negotiating. This idea that we, the lone maker, can put our name on stuff and be famous seems like a pretty big problem. And it's been kind of lovely that within the group of people who I know are really advancing like textiles and electronics, most of them are doing it open source and collectively. And it's always about keeping it within the community. And every so often, one of their things gets patented by someone else. Right. So I do feel like there was also sort of an inbuilt, it's just a lack of desire to even want to put your name on it. Why would I claim credit for work that's been around for centuries? So maybe by calling it the Jacquard loom, it's a bit of a diss. Like somebody had to thought they were important enough.
Yeah.
And I guess that was part of naming it AdaCAD, because it was sort of wanting to like, I mean, it was definitely named for the Adas who weave. And it was short and sweet.
Yeah, I think it's super important, because I think once you stick your name on something, it limits it to your lifetime. When something like craft is, it grows through being passed through the generations, and
and it's just one way. It's not the way. And so what I liked about switching from the canvas model is because the canvas model like implicitly made all of the ways I thought about weaving default functions, and you would have to use those to do anything. But the nice thing about this kind of generative approach is that you can have this ecosystem of different ways of doing the same thing, and that people could come in and craft that in different ways. So it felt like there was a little bit more of like a polyvocal design ecosystem, instead of just being like, no, I made it this way, you need to work this way. Yeah.
So we have quite a few questions coming in about AdaCAD itself. There's one here from Helena. Will AdaCAD also analyze an existing pattern and create the weave draft? So can it go backwards?
No, but yes, please. I mean, I've written different proposals that are about analyzing structures and generating drafts. I haven't necessarily had the time or expertise in-house to do that, or just scanning in historical drafts and then being able to kind of encode them in this like unified format. I think there's definitely people out there that are starting to work on that more. But as an open source free software, my hope is that somebody else might come in and write certain operations for that, and I'd be on board for doing some co-programming.
Cool. So you accept pull requests.
Okay. Oh, yes.
Yeah, so another question from Michael. I think you have a way to code a third state in which a thread is not present. Can this become a basis for lace weaves?
Ooh. Perhaps. I haven't done much lace weaving, so I don't know. But I would love to play with that more. And I will say that one of the things, when I've woven structures that have more openings in them, I start tooling more with the machine functions than the draft. So for instance, like if I want to create, and I am not a lace maker, so this might be sacrilegious, but if I wanted to create a more lacy structure, I usually advance my warp so it's pretty thick, and then I beat really hard so that it kind of becomes wavy and joins in that way. And so I have a student, Chanel Wu, right now, who's working on more interfaces between AdaCAD and the machinery. So trying to create something that's like a guitar pedal so that you can write different functions directly on the loom and you don't have to do this whole pre-designed thing. And that's thinking mostly about working with a TC2 because floor looms are already pretty improvisational. Yeah, there's so much more to learn. And maybe this is a good segue into studying lace structures.
Yeah, I think there's so many different parts just of weaving to learn, to get deep in. From the outside, it seems like weaving or even textiles is a thing that you become expert in. But there's so many different worlds in textiles, and it can be to the point where a knitter might not have that much to say to a weaver if they were both really deep in their own practice, because there's such different structures, even though the elements are the same.
When it fills your brain, I mean, it's like there's a calculus to it that you really, you develop your own patterns of like your own compression systems or whatever in your brain just to manage your own knowledge set and to think with it. And I find that weavers do that, maybe knitters too, in really personal ways. And so it's also sometimes just there isn't a universal yet. And that's actually kind of what I like about it.
Yeah. But I suppose you're bridging different worlds, aren't you, as an engineer, as an artist, as a researcher, and also as a computer programmer and a weaver. So how does it feel to jump between the mode of programming AdaCAD and using it? Is that a continuum, or does it feel like you're jumping into a different part of your brain?
It depends.
Or is it all drafting?
Yeah. I mean, there's definitely been ways where I wanted to make something and I needed AdaCAD to help me make it because I didn't know how else to do it. But then also I find programming to be oddly therapeutic. And so for me, you'll see that AdaCAD had a lot of GitHub commits around COVID time, because it just gave me a sense of control. Like, oh, I could go in there and I can write code and I can see something happen on a screen and I can be in charge of that little world.
Yeah.
So I think if you're seeing a lot of GitHub commits, you might suggest I go talk to my therapist. but yeah, I mean, I also get a little, it's like when people write software and they write it and it's so technically cool, but what you actually make with it or what the experience of it isn't very interesting, that I worry about doing that. Like, oh, I made these amazing technical weaves, but then actually plain weave is really amazing. And oftentimes I just want to do plain weave. Because it becomes more fun to play with the materials. This becomes its own exercise and like just math for the sake of math sometimes.
Nice.
Yeah.
Well, we'll try and fit in a couple more questions because we're coming up to the hour. So here's one. So this is from a textile designer asking about cellular automata. So Mika Satomi, who I think we both are in contact with, is leading this course and using cellular automata to generate algorithms for patterns. Is it possible to do this in AdaCAD?
Yeah, I mean, not with the existing function set, but it wouldn't be hard to write your own operation. So if you could sort of sketch it out in terms of like, what are the inputs and the parameters and what are the outputs? The part of AdaCAD where all the operations are defined is just in one file. So you could fork it and add it in, or just send me the algorithm and I can do it, because that would be fun. I don't know Mika personally, but I definitely admire her work.
Yeah, she says. Yeah, I was just thinking that maybe you could see weaving as a form of cellular automata anyway, when it comes to combining different structures. Maybe there's something, maybe it's even your system is already Turing complete and you can do some kind of, yeah, anyway, that's just a passing thought.
It would be fun to have a separate call where we play with that. That would be interesting.
Definitely, yeah. So let's try and get through these. Does AdaCAD allow pattern making using tablet weaving technique? Is there a function already? That's opening a whole new can of worms, I think, there, like the lace making.
Gosh. By tablet weaving, is that the or is that harness loom weaving? Not sure if I know exactly what
tablet weaving is the thing with the cards,
thing with the rotations.
Twist. Yeah.
No, but as I was researching this, are you on a collaboration that did a lot of that, Alex? Because I was looking up, somebody has like a generative system for tablet weaving, or at least has sketched out the design space of it. AdaCAD doesn't have it, but I could search around and find it again.
Yeah, okay, yeah. Dave Griffiths, my collaborator, has made some web software. Maybe, I know he's on the course somewhere, maybe
okay.
Where you can play around with it on the web. I'm not sure if that's...
yeah, I mean, that's pretty magical. About. And that, I haven't even wrapped my head around tablet weaving.
Yeah, it's a whole other world. I was talking to Sarah Williams, who might actually be on this call, who's a local weaver here in Sheffield, and she gave a tablet weaving workshop for us a while ago. And she was saying that her weaver friends think that she's a bit unusual in having this interest in tablet weaving, because it is a whole other world. It's like a mixture of braiding with weaving, I think.
Oh, it's fun though, and it
is amazing. Yeah,
it gets deep.
Yeah, also known as card weaving.
Yeah.
So let's try and get through two more questions. So one from Helena: what do you mean by the canvas way? I didn't pick up when you said that, actually. But
I mentioned like the older versions of AdaCAD were in this canvas paradigm. So this is the idea that you get a blank draft and then you start filling in the cells. So the idea that you're starting maybe from the global picture of what you want to weave and then drawing in the different parts. So I thought of that as like when you approach a blank canvas and you start painting, where this is much more like collage. So you're assembling little bits together, and you're growing the global thing from all these little local parts. So I saw those as maybe two different things. Yeah.
Okay. Okay, one more from Anu. You mentioned the weaving loom is your 3D printer, but there are yarn practices like crochet that doesn't have its own machine, but still produces 3D print-like objects. Could you expand on that?
Yeah, I mean, I think maybe a better way I should have said it is that the weaving loom is a 3D printer, but it's not the only one, right? I think almost all textile techniques are three-dimensional. And I guess it was quite wild to me that they weren't considered so heavily when we talked about the maker movement and generative design and 3D printing and things like that. I think the difference is those had machines where we didn't seem to think of people's hands as machines anymore. But the thing that's so magical about crochet is that, what is magical about? There is no machine that can do crochet. That's right, isn't it? So it's almost kind of interesting in that you can't mechanize it, or no one's mechanized it to date. So it's like really resisting that move. But crochet can be a really great way to do 3D. There was some researchers like Takeo Igarashi, even 10 years ago, created some software that would compile 3D shapes to crochet patterns. Though some of the paper call them knitting, but I think they're actually crochet. And now work by like Leia and Jim McCann out of CMU is doing like compiling 3D models to knit structures as well. So I'm just sort of sitting in my little weaving corner, and letting the super smart graphics people do knitting.
Yeah, maybe we have Jacquard to blame for the idea that weaving is two-dimensional, because it does make it very easy, I think, to print out a fabric with a two-dimensional design on it. And maybe actually we could say that weaving isn't, there's plenty in weaving which you wouldn't be able to do to automate, which is why you mentioned the TC2 earlier, which is sort of semi-automated, but you have this hands-on control of passing the weft. And I suppose the reason for that is that there's things that you can explore which could be supported by machines, but which you really need to be hands-on to really do.
You gotta feel the materials fighting you, or else you can't. I don't know. It's just, I like feeling the materials and seeing how they're responding. And
there's something in that paper I started with, I think, where it says the material, you touch the material and it touches you back. It's like a two-way exchange. Brilliant. Well, thank you so much. This has been really fun. Yes. Please do continue to explore AdaCAD. Maybe we'll make a thread on the algorithmicpattern.org forum for sharing patterns and ideas. Or have you got a forum of your own, Laura?
A forum. I mean, actually, that would be a great forum for it.
Okay. We'll start there. And yeah, look up the other talks which are happening over the next weeks, about one per week. And yes, see you on the forum or wherever. And yeah, thanks for joining us, everyone.
Thanks for having me.
I'm not sure what more to say, but yeah, we won't be able to hear your applause, but I'm sure everyone's very happy.
Clap for us.
Yeah,
this is for you.
It's a bit strange at the end of these things. You're kind of waiting for the audience to respond, but yeah, but that's life in these days. But yeah, all the best. Thanks, everyone. Bye.
Bye.